Kusog din. Okay. Sige, let's continue. We have class the aromatic compound. So this one is another group or is another functional group, I mean. So after alkanes, alkenes, and alkynes, we have now the aromatic compounds, which are also composed of carbon and hydrogen, but there can be substitutions also here. So just like the alkenes, alkenes, and alkynes. Now, what is unique about aromatic compounds? These are the compounds that contain benzene ring in their structures. Okay? They have benzene ring and they follow the so-called Hackels Rule. Okay? Kasi marami tayo class ring, naka-ring na substance. Kung titingnan natin yung kanilang structure, naka-ring sila, pero not all ring compounds are considered aromatic. So we have to check first with the Hackels Rule if they are really aromatic. So when you say benzene, they are also called benzol. So these are some important aromatic compounds. We have here the Fenantrine, which is part of the structure of the CPPP nucleus, or the so-called, let me type it sa screen, the cyclopentanoperhydrophenanthrin. So ano itong CPPP nucleus na ito? If you see this sa structure of a compound, it means the compound is ano siya? Steroid. Okay. So again, steroidal siya kapag meron siyang CPPP nucleus. So a part of the CPPP nucleus is the so-called phenanthrin. Mas malaki lang itong cyclopentanoperhydrophenanthrin. And then we also have here another example of aromatic compound, the benzopyrene, which is one substance that is also found in cigarettes, and this can be the cause, or this can be responsible to the cancer na kinokos ng cigarette smoking. Okay? So the benzopyrene can actually be metabolized or pwede siyang separated into phenanthrin and pyrene. So pwede siya i-process so that we can get the two compounds, but all of them are considered aromatic. So balikan natin si Hackels Rule. This is how we know if the substance again is aromatic or not. Ay, luag ako ang wait lang ha, I'll just na USB something. Ang lag. Labay ko na kong laptop. Umagi na siya. Okay, umagi na siya. Okay, for the Hackels Rule, we have 4n plus 2 equals pi electron. This is again our formula for us to know whether a substance is aromatic or not. Now, ang hahanapin natin here is the n. So, like for example, you have a benzene ring. This one is your benzene ring. So 4n plus 2, and these pi electrons are the electrons involved in the double bond. Now, how do we count them? This one, itong tatlo are the double bonds. The electrons there, we have 1, 2, 3, 4, 5, and 6. So for hexane, for benzene, I mean, we have a total of 6 pi electrons. So we will place it there for the pi electron, and then we will do the math. So for 4n, let's transfer the 2 on the other side. So this becomes negative. 4n is equal to 4. Divide 4. And then we will have n is equal to 1. Now, how do we interpret the result of the Hackels Rule? If you get a whole number, positive in nabuang niya akong pen. Buang na akong pen, sorry. Okay, again, if you get a whole number, positive integer, positive integer class, it means that yes, our substance is aromatic. So just like this one, the result for benzene is equal to 1. That's a whole number and that is positive. Then definitely the benzene ring is aromatic. Okay? Pero for example, you have here this one. Okay? Isang double bond lang siya, unlike the benzene. It's a ring but you have only one double bond. So you can still compute though for the Hackels rule for the N. 4N plus 2 is equal to pi electron pa rin siya. Pero what is the pi electron here? You only have 1 and 2. So you have again 2 pi electrons for this one. So you have 4n, 2 minus 2, 4n is equal to 0. Even if you divide both sides with 4, you will still get 0. So 0 is not counted there. Remember, we need whole numbers or positive integers. So this one, though it is a ring, it is not considered an aromatic compound. So it is just a cyclic alkene. Okay, alkene lang siya pero naka-ring. Hindi siya totally aromatic. So the rest na binigay ko like the phenantrine and the benzopyrene, you can actually check class whether they are really aromatic or not. So just count the number of pi electrons sa lahat ng side or sa lahat ng terminal side ng double bond. Okay? Now, classification of our aromatic compounds. They can be monosubstituted, disubstituted, tri, or even polysubstituted. Okay? So, depende kung ilang branches ang meron. Siyempre, I believe you know the meaning of the mono, the di, the tri, and the poly. Now, we also have the so-called polycyclic or fused aromatic compound. Actually, our previous examples, the phenantrine, the benzopyrene, and even the pyrene are under here. The polycyclic or those na may mga fused rings sila. So as you can see, madaming ring na pinagdugtong-dugtong. That's what you mean with polycyclic or fused aromatic compound. Okay, now this one is an example of a monosubstituted aromatic ring. You have here the benzene, and then you have there the HNO3. This is actually nitric acid. With the help of the concentrated sulfuric acid that will act as catalyst, you will get the nitrobenzene. So isang substitution lang, kaya tinatawag siyang monosubstituted. Even the chlorobenzene and this ethylbenzene also, these are all examples of monosubstituted. And these are the examples of our disubstituted. So as you can see, you have there the hydroquinone. They are all OH yung substitution, but different locations. So you have here the ortho, the meta, and the para. Baliktad ito. Dito yung ortho, ito yung meta, and this is the para. So the para-hydroxybenzene is called the hydroquinone. The meta is called resorcinol. And then you have the catechol for the ortho. Okay, the 1, 2 na position. But nevertheless, these are called disubstituted aromatic compounds. And this one is the trisubstituted. How do you call this compound? If you see this, ang tawag sa kanya? I'm looking for something. Anyone? Well, I'm looking for something in... Wait lang. Ulat ko sa inyo answer na ng Jupiter. Pangitaan. Oh. Okay. 135 trinitrobenzene. Okay. Okay. Again, this is 135 trinitrobenzene. If like we add one CH3 here, this will become polysubstituted na aromatic compound. How do you call this? If yung kanina is 135 trinitrobenzene, how about this? Tawag natin dito. If we are going to add 1 CH3. Ang tawag dyan. Anyone? Wala? Sure na? This is what you call the trinitrotoluene or the TNT, yung ginagamit na explosive. Okay? But I believe you heard about TNT. It's trinitrotoluene and this one is the structure. So it's a polysubstituted aromatic compound. Okay? TNT, oo, TNT. Trinitrotoluene. That's the meaning of TNT. Trinitrotoluene. Have you heard about this? Nagamit nilang pampasabog. Explosive. Lahi na TNT mo na
Makita
pala.
lang sa ano, ma'am, yung sa cartoons, good, ma'am. Pag may mga label, pag may mga bomb something TNT ang nakalagay.
Yeah, that's it. Yeah. Yan yung pinapasabog nila, TNT. Trinitrotoluene. It's just a chemical substance, but it can cause explosion. Okay? The TNT, trinitrotoluene. I'm not really familiar with the other name of the trinitrotoluene. I just know that it is TNT and it is trinitrotoluene and this is the structure. Kung like layman's term lang, I don't know the layman's term for the trinitrotoluene. Let us check. That is not also hindi din siya component ng dynamite. The dynamite uses other pampasabog including nitroglycerin. Pero ito, iba din siya na explosive. I don't know the common name for this. Ang alam ko lang is TNT. Okay? Sige, now let's move on to the reactions of our aromatic compounds. Dili siya. That's the ayupak name. That's the ayupak name, Jai. Pero the trinitrotoluene is also considered. Kasi when you say toluene, that is a benzene ring with CH3. Okay? With CH3 ang meaning ng toluene. Okay? Now, reactions of aromatic compounds. We have electrophilic aromatic substitution. Meaning, in your benzene ring, there will be a substitution of an electrophile or an electron-rich na, or electron-loving, I mean, na compound. So instead of the hydrogens bonded in the carbon involved in the benzene ring, papalitan natin. And we have different types of electrophilic aromatic substitutions. We have nitration, halogenation, Friedel-Crafts alkylation, the Friedel-Crafts acylation, and lastly, the sulfonation. Now, what are you going to be familiar with the electrophilic aromatic substitution? Number one, the reagents and yung electrophile. Okay, yung electrophile. So first, we have the nitration. So suppose you have a benzene ring and then anyway, this one is a benzene ring. And take note of the reagents. We have the nitric acid and the sulfuric acid. So the one that is actually the true reagent there is the nitric acid, and the sulfuric acid will act as a catalyst, actually a Lewis acid catalyst. And this will just facilitate the reaction. So after that, after reacting, you will have substitution here. So one hydrogen in a carbon will be substituted. Take note of the electrophile, it's NO2. NO2 ni siya ha, NO2. But anyway, we have here, balik, kaning 2 plus, di rin na siya sa babahan niya, ang charge niya positive. Okay. So, ang iyahang, product is this one. Siyempre, we call this nitrobenzene. So, anong tawag dito? Nitration. We will have a nitrate na ilalagay, or not really nitrate, the nitrite actually, ilalagay natin, isasubstitute natin with one of the hydrogens found in a carbon in the benzene ring. So when you say nitration, please remember the reagent is the nitric acid, sulfuric acid will become the catalyst, and yung electrophile here is the nitronium ion. So it will be a branch, or it will be a substituent in the benzene ring. The resulting compound is called nitrobenzene. So that's the first reaction na ma-undergo ng ating aromatic compounds. Now, the second one is called the halogenation. From the name itself, halogenation, syempre halogens. So, ang symbol ng halogens natin is X2 kasi syempre they are part of the diatomic molecules. Do not forget our diatomic molecules had the Birchnow. The Birchnow. Ano yan sila? Bromine, iodine, C is for chlorine, hydrogen, nitrogen, oxygen, and fluorine. Ito yung mga elements natin. They don't exist as single atom freely in nature. So they always come in 2 atoms. That is why we have diatomic molecules. And included there are the halogens. So like Cl, Cl2 siya, or Br2. Merong subscript which means dalawang atoms. And then just like the nitration, we also have the Lewis acid here na mag-a-act as catalyst. So the Lewis acid is a combination of iron and the halogen. Okay? Whatever halogen yan. Pwedeng chlorine, pwedeng bromine. But our electrophile here is the halogen itself. So we call that halonium ion. So let me give you an example. We have here a benzene ring, and then example, gagamitin natin for halogenation is chlorine. So chlorine will become the reagent, and then the Lewis acid or the catalyst will be FeCl2. Okay, take note Fe and then the X. So FeCl2 will be the catalyst to hasten or to speed up the reaction. And what will be our product? Our product here will be this one. Okay? One chlorine only ha. Isang chlorine lang yung magiging product natin. And this will be called, syempre, chlorobenzene. Okay? So yung isang chlorine dyan, actually pwede tayong mag-add ng HCl. The hydrogen being displaced plus the extra chlorine will give you hydrochloric acid. But nevertheless, this one is the important product, the chlorobenzene. This is what we call halogenation reaction. Any questions so far? Paano ma-memorize? Paano ma-memorize ang reagents the easiest way? Actually, my problem when giving reviews is hindi ako yung lecturer na maraming mnemonics. May mga magagaling kasi talaga na lecturers na they can easily make mnemonics for you to easily also memorize a lot of things. My problem is mnemonics make me more confused. So I'd rather memorize everything than have mnemonics. So just like this one, eto, kung ako ang nag-study ani man good, when I say nitration, I don't know, I just memorized when I say nitration, that's nitric acid, sulfuric acid will become sulfuric acid will become the catalyst, and then from the HNO3, NO2 will be the electrophile. Yan yung idudugtong sa benzene ring. And then for halogenation, automatic, that's for the halogen. Any halogen na diatomic molecule, and then meron siyang catalyst na combined with the iron. And then the halogen mismo yung magiging reagent. Okay? Meron akong mga mnemonics pero very limited. Okay? Very limited. So, kaya pag mag-review tayo, we'll find like lecturers na magaling with mnemonics kasi daghan jud na siya kaayo. And I don't know kung paano na ko na siya gi-memorize. Basta tong nag-study ko for the boards, nag-memorize lang jud ko. Nag-memorize lang jud ko. Pero actually, hindi naman ako gaanong slow, pero I see to it that in a day, makabasa gyud ko kung like bisag pila lang kabuok na concept in a subject. So when I prepared for the board exam, nastudihan syempre nako tanang subjects. Ang ako lang wala jud na human during the preparation sa boards ay kanang mga reviewer, kanang Pakop, napay uban na mga reviewers, mga Appleton, o kanang mga unsa-unsa pa dinha ng mga available reviewers. So kanang mga series of questions, kana lang ako wala na human. Pero tong ako magud ang nag-study ay more on notes jud ko. So notes, and then gigamit lang nako ang reviewer katong hapit na ang board exam as like para sa ako amor siya kanang to test if na-retain jud ba sa ako ang memory ang ako ang mga gitang studyhan na notes. So gina-answeran ako tong mga questions sa mga reviewers, and then I checked whether tama akong answer kasi ang mga reviewers meron naman yan silang answer sa likod, pero dili man gud tanan tama. So pag diskumpiyado gay ko sa answer sa reviewer, naga-research pud ko kung unsa gyud ba ang tama nga answer. Yeah, dili jud tanan effective. Dili jud sa tanan effective ang mnemonics. So ako pud gyud ang isa ka example dinha. Dili jud ko more into mnemonics kay malibog hinuon ko bonggang-bongga kung
Ma'am, kung ma-memorize na akong mnemonics, ma'am, makalimot ko sa iyang meaning.
Ay, kabalo ka sa iyang mnemonics pero wala na, ay, kabalo na ka sa mnemonics, memorize kayo ng mnemonics pero nakalimot ko kasi meaning atong M sa imong mnemonics. Wala kay ko naga mnemonics class. Pero if very effective sa inyo ha ang mnemonics, I'll try to look for some kasi even up to now, if you look at my notes, wala jud ko yung mnemonics. Even if yung mga teachers nagtuturo ng mnemonics, hindi ko kasi sila ginagamit. Kaya hindi siya makikita sa notes ko. But I'll try to look for the others. Ikaw, mnemonics imong lifesaver. So, kanya-kanya jud taan ni og kanang trip sa life. Depende kasi kung ano yung maging effective for us, no? Depende na yun na siya. Pero if I have mnemonics, I will really give the mnemonics sa inyo ha. But this time I don't have mnemonics for this. Okay? And then actually sa tanan klaseng chemistry, lowest na ko ni siya ang organic chemistry. I don't like this. I don't like this. Kuya, oy, gira-convert ang cellphone. Karoon ako kamatayan na. Karoon ako kamatayan na. Kuya, wag mnemonics. Ano kayo mga mnemonics? Like the very common dumbbells. Si Gary V na isang CP nagpa-BP. Ano lang akong dili malimtan.
Leora.
Mnemonics, Leora, Jeroa, oil rig. Kana lang. Kana ganing mnemonics sa physical pharmacy about sa solubility kanang gong freely soluble kanang mga very insoluble naagod na sila mnemonics ay, and then ginatudlo na siya. Diba, I've been into a lot of review centers, ginatudlo gid na siya mnemonics pero wala jud ko'y mahinumduman karon. Ako matandaan na lang yun ng isa kapi din kay president. Tapos kay pag sige memorize president, unsa na ganing meaning atong president o nga partially soluble na bato or unsa na bato. Ayoko kahinumdum. So I'm opting to memorize everything na lang. So pag pangutanon ko nimo like solubility terms, kabalo ko na like when you say soluble 10 to 30 na siya, 10 to 30 parts of the solvent ang kailangan to dissolve one part of the solute. Kana, kabalo ko na 10 to 30, 30 to 100, 100 to 1,000 niya. Ilang mga corresponding verbal terms. Pero ayaw ko yung mga tanag mnemonics kayo. Wala, ginasunod na ko na siya tanan sa akong utak. Gina-try dyan ako na siya memorize tanan. Kanang mga RA. Actually, ako memorize yung Kumito na ako lowest na board exam, di ba? Ang lowest na board exam ka ng Area 5, DBS, Mano, Pharm, Jurisprudence. Sakit ka na sa, sakit ka na siya sa liog. Kay tagas kayo ang mga questions. Pero I think sa mga previous na mga batches, mag Area 2, Manila hangin na reklamo. So that is the reason why I want to have the PCOG and the biochem since isa man na sila ka-area sa Area 2. Okay, next we have the Friedel-Crafts alkylation. So from the word alkylation, we have here the alkyl group that will become the substituent. So what are the reagents for our Friedel-Crafts alkylation? We have here the RCl, R being any functional group. So most like this one is an alkyl. And then still we have catalyst. So most of the reactions involving aromatic compounds do have catalyst to aid the reaction or to speed up the reaction. So in this case, we have the aluminum chloride as the Lewis acid catalyst. Now, what will be the electrophile for Friedel-Crafts alkylation? You have there the R+. So not the chlorine, but the R. Or we call that carbocation or carbonium ion. So what is the example of this? So you have here another benzene ring. And then for example, you have this one, CH3Cl. So you have here a methyl group. Remember this one is alkyl. So you have methyl chloride or chloromethane. The other one is the common name, and then the other one is the IUPAC name. Now take note that for Friedel-Crafts alkylation, ang R yung ating substituent or yung ating electrophile. So this part here will be the substituent. So our product here becomes this one. The CH3 will become the substituent. And then you will have hydrochloric acid also, the hydrogen being displaced in this part, and the Cl. Do not forget the Lewis acid catalyst. So pag narinig nyo yung alkylation, think of the hydrocarbons. Kasi mo na siyang ato ang alkyl, di ba? Alkyls are just alkanes minus one hydrogen. So this time we have the methyl. If you have the ethyl, parehas pa rin naman siya. Like you have an aromatic compound like the benzene plus the CH3, CH2Cl, that is the chloroethane. You still have the Lewis acid aluminum chloride. This part will still become the substituent. So you will have CH2, CH3. Okay? The hydrogen being displaced together with the chlorine from the reagent. But nevertheless, we call this alkylation because we have here the alkyl group being the substituent. Okay? And then we have the Friedel-Crafts acylation. So parehas silang name ha. The other one is alkylation. The second one is acylation. What is the difference between alkyl and acyl? For reagents, this one is, take note of this. Ano yung nadagdag? C double bond O. Kanina RCl lang. Ito may nadagdag na C double bond O. Though we still have the same catalyst, the aluminum chloride. So itong RCO will become now the substituent. This RCO is called acylium ion. Kaya tinawag siyang Friedel-Crafts acylation. So example, we have here a benzene ring. This one is a benzene ring plus a CH3. And then meron kang C double bond O. And then on the other side, you have the Cl. Sorry. Tarungan na lang ako siya. So this is the R, and then we have C double bond O, and then you have the Cl. So this one is an example of it. CH3, this is the R group here, and then the C double bond O at the center, and then lastly you have the Cl. So this part here will become the so-called acylium ion, and during the reaction for the Friedel-Crafts acylation, yan yung magiging substituent natin. So this one will be connected sa ating benzene ring. Okay, so anong part yung mako-connect? It's actually the carbon in between, yung merong double bond O. So you have the CH3. So hindi ito kasali ang Cl. Okay, ito lang na part. Pero ang connection is dito sa gitna. Yan yung tinatawag na acylium ion, and that will be the electrophile being used as a substituent for the aromatic compound. Okay, questions or clarifications about this? Wala? Sure na. Well, let's move on. We have the sulfonation. Again, we have the sulfonation here. For the sulfonation, syempre from the name itself, we'll have a hint na it's talking about the sulfate. Okay? So we have here the following reagents. The SO3 plus the concentrated sulfuric acid. Actually, the concentrated sulfuric acid will become the catalyst here. So ito yung totoong reagent. sulfur trioxide. So we have here a benzene ring plus the SO3. Pero you have here the sulfuric acid that will act as the catalyst. But take note of the electrophile. It's not just SO3, but including one of the hydrogens from our concentrated sulfuric acid. So, ang product nito is this one. This is called sulfonium ion ha. Now, saan yung connection? The connection will be sa sulfur, SO3H. Magiging SO3H siya. Tawag natin dito, benzene sulfonic acid. Okay? Yan yung, again, pangalan ng product for the sulfonation. So please be mindful of the reagent. It is SO3. This one, the fuming or the concentrated sulfuric acid will act as catalyst, but the electrophile, the one that will be substituted in the benzene ring is the sulfonium ion. The product will be called benzene sulfonic acid. Okay? So these are all the reactions na pwedeng mangyari for our aromatic compounds. Okay, let's summarize again. We have the nitration, syempre nitric acid, and then you have there the sulfuric acid as the catalyst. Our electrophile is the nitronium ion. Halogenation, we have the halogens, whether chlorine, bromine, fluorine, or iodine. And then we have the combination of iron and the halogen that will act as the catalyst. Now, the halogen, syempre, will be the electrophile here. Friedel-Crafts alkylation. So this is just an alkyl, meaning hydrocarbon lang siya. So it's an alkane with -1 na hydrogen. Yun yung idudugtong natin sa aromatic compound. And then this one is Friedel-Crafts acylation. Pag acylation, we need the acylium ion. And when you say acylium ion, that's RC double bond O. So ito hydrocarbon lang for alkylation. Ito naman acylation, RC double bond O. And lastly, we have the sulfonation. So ang ating electrophile here is the sulfonium ion, that's HSO3, and then the concentrated sulfuric acid will just act as a catalyst. Okay, again, that's all. That's the reaction for all of our aromatic compounds. Questions so far? Sa mga reactions, kasi natulog na sila una, baka gikapoy, nag-duty kahapon, nagklase si mamabigay na, tapos madugo ang organic chemistry. Sige, walay question. Now, let's talk about the ortho and para directing or even the meta deactivators. Let me write sa screen. Ang ibig sabihin ng ortho class, ortho is 1, 3. Ang meta, 1, 3. 1, 2. Ang meta is 1, 3.
1, 3.
And the last one, the para is
1, 4.
4. Okay, now we have the so-called the activators and activators. These substances will direct, okay, this will direct the position of the electrophile to the benzene ring. So for example, you have a benzene ring and originally meron siyang isang ito OH. For example, meron na siyang OH. So phenol na siya, no? Now kung magdagdag ka pa ng another electrophile class, the presence of this OH will direct ortho or para position. Therefore, yung kanyang product will still have the OH here, but the electrophile can be, again, ortho. So, pwede siyang dito, or pwede din siyang para. Okay? So, the OH will still be there, but the electrophile will will be here sa para position. Yan yung ibig sabihin class ng ortho and para directing activators. Now, activators ang tawag sa kanila because they will activate the aromatic ring. Bakit nila i-activate? These are the substance that will donate electrons to the aromatic ring. So magiging active siya, but the electrophile will be positioned either in the para or the ortho positions. Okay? Sige. Now, what are these substances that will direct ortho and para positions? We have strongly activating like the hydroxides, the amines, the NHR, NR, or OR. R can be any functional group, but most of the time that will be an alkyl. Now, moderately activating, we have here an ester and an amide. So, syempre, this one is an ester, this one is an amide. And we also have weakly activating, so we have RCH double bond CH2, meaning we have here an alkene. R is any functional group, so pwede din siyang any na like pwede din siyang carbon, hydrogen, or hydrocarbons na dugtong-dugtong or a chain. And then the phenyl group is also a weakly activating na ortho and para. So again, anong ibig sabihin nito? If they are already positioned in an aromatic ring, they will direct the position of another electrophile sa ortho and sa para position. So activator sila kasi they will activate the benzene ring just by donating their electrons. Now, we also have the so-called meta-directing deactivators. So, ang position naman na ida-direct nila is on the meta position. But they are deactivators because they will render the aromatic ring less active since hihilain nila papunta sa kanila yung electrons ng aromatic ring. So baliktad ang activator sa activator, yung ring ang magiging active kasi magdo-donate itong mga functional groups na ito ng electrons sa aromatic ring. Pero pag deactivators, baliktad. The electrons of the benzene ring will be drawn doon sa ating functional groups or sa ating substituent. But the position will be meta. So example, you have here an example. We have like NO. So example, nalagay siya dyan sa NO or even si NO2. Kapag kaandyan na siya, tapos magdagdag ka pa ng another na electrophile class, any species, basta electrophile pa rin siya, ida-direct niya yan sa meta position. So the result will be this one. Ano yung meta nga? Meta is 1, 3. So if NO is located here, 1, 2, 3, the electrophile will be positioned here. Okay, so please take note kung sino-sino gani kay wala jud ko maisip nga ni Monique sa aning class sa kadaghan nila no, ang dapat na tumabalan whether they are ortho and para directing activators or meta directing deactivators. Deactivators ang meta directing they will deactivate the ring by pulling the electrons towards themselves. Okay? Now, the last one are the ortho and para directing deactivators. And madali lang siya actually i-memorize because these are just the halogens. The halogens are ortho and para directing deactivators. Like meron kang benzene ring and then we have the halogen here, like the chlorine. Chlorine is ortho and para directing. So, pag mag-add ka ng electrophile, the product or the products can be positioned sa ortho, pwede din siyang sa para. So, kagaya siya kanina sa, wait lang, ha? This is, lipat ko ng CL dito ha. And then this will be the E plus here. So it's either ortho position or para position for the electrophile na ikakabit natin. Anong kaibahan? Baka magtaka kayo, ma'am, huma naman ng ortho and para. Take note that these are activators. So they will donate electrons to the benzene ring and make the benzene ring more active. But this time, itong mga halogens will be the activators. They will pull the electrons toward themselves. Remember, they have high electronegativity value. So, sinabing electronegativity, that's the ability of the atom to attract electrons. So, especially fluorine, the most electronegative element, talagang hihilain niya papunta sa sarili niya yung electrons ng ating benzene. So, meaning yan, made-deactivate, magiging less reactive yung ating benzene ring. Pero, the resulting product for the addition of this electrophile will either be an ortho and a para. So, I hope naintindihan yan. And again, kailangan yung malaman which of them ang ortho and para directing activators, the method directing deactivators, and the ortho and para directing deactivators. Okay, questions before tayo mag-move on sa alcohols? Nabay pangutana? Kamu lisuda no, kamu ang ma-deactivate. Dili ang benzene ring ang ma-deactivate. So napod tayo mga ingana sa life no na ay mga magpa-activate sa tua by donating something. And meron din namang mag-suck out ng ating energy making us deactivated. Okay sana sa review actually class kasi purely review lang talaga ang gagawin ninyo. So I hope by that time na magre-review kayo, yung ideal talaga is sana walang distractions. Hindi kayo mag-work kasi minsan may mga nagsasabay work and review. And you know the feeling, even if you are just interns ngayon, pero it's like you are working inside a pharmacy and you know the feeling na mag-duty tibok adlaw. So pagka abot ana sa balay, murag kapoy jud kaayo na siya, you cannot really concentrate with the review. So again, the ideal is just concentrate with your review. Then ang pag-work, sa sunod na lang sa if meron namang ikasupport yung inyong family sa inyo for the review, ayun na lang sa magtrabaho. But I can understand those na as in walang-wala talaga, so they have to really i-double ang tanan, effort, magtrabaho pa, mag-review pa. Okay, pero dili man gud siya maka-concentrate. Yeah, okay din naman mag-self-review, pero kanya-kanya lang talaga tayo ng class. Kanya-kanya lang tayo ng study habit, kanya-kanya tayo ng way para matandaan ni tanan sa kadaghan. So okay ra kayo ng self-review if effective siya and wala kay distractions. So like sa time nila Ma'am Cherry, I know na siya classmate na nag-self-review kasi nga wala talagang ikabayad sa review center. Actually, kung nag-estudyante pa siya na ay mga times na amutan siya sa iyang mga classmates para makatake siya sa exam. Niya, ginahinay-hinayan nang bayad ang iyang mga classmates. Hangtod sa naka-graduate jud siya. And then after graduating, wala po jud siya ibayad sa review center. Batch na siya ni Ma'am Cherry. So, kato, nag-self-review siya. Pero one take lang siya ha. One take lang siya. Pero wala siya nakatake sabay ila Ma'am Cherry kay syempre she needed more time for studying since pinagsabay niya din yung work and yung pag-review. So kung kaya ninyo to, why not? Pero kung sa tanaw ninyo murag lisod kayo. Lisod kayo, you know the feeling na mag-work class. Actually, mas nindot estudyante. Pag estudyante manggugay, you have all the time sa world. Gipit lang ka sa kwarta, kaya wala mo kay income, you have all the energy. Pero kapag ka nag-graduate na kayo and mag-work na kayo, you have your income, so you have your own money, but you don't have all the time of the world. Kailangan ni mo mag-duty, tapos pagka human duty, wala kay energy. Parehas karon pag human sa kong klase, wala ko energy. Mag-check up sa inyong exam. Okay, now we have, wala na question about the aromatic compounds. Let's move on to another functional group, the alcohols. Our general formula for alcohols, we have the ROH. Okay, ROH. And itong hydroxide, this OH being bonded to our R group is any functional group. So it can be an alkane, alkene, alkyne, or it can even be an aromatic ring. Now again, the OH groups can form ion dipole and hydrogen bonds. So that is the reason why alcohols can be miscible or even miscible lang and can react with or interact with other substances because again, the OH here is capable of forming hydrogen bonds and at the same time ion dipole. So you have here the dipole, the OH na group, and then magre-react siya with another ion. So pwede siya like sodium, potassium, magnesium, pwedeng mag-react dyan, mag-form ng link or bond with alcohol. And then OH groups enhance water solubility. So the presence of the hydroxide ion will actually explain why alcohol can be miscible in water. Pwede, miscible sa water yung ating alcohol. And for the pharmaceutical world, the alcohols can be esterified to form prodrugs. So, ito yung ginagawa nila if they want to make prodrugs. Remember when you say prodrugs, these are drugs that are inactive outside the body, but when metabolized, they will be activated, and that's the time they can elicit their pharmacological action. But again, if you have a compound and you want to make it a prodrug, if there is the presence of the hydroxide ion or the alcohol functional group itself, it can be esterified. It can be converted into esters. We'll talk about esters later. And then magiging prodrug na siya. Okay, now inside the body, if like we consume alcohols, literally the alcohol, the liquor, or anything that contains alcohol in the structure, how do we metabolize that? We metabolize that through oxidation for the first part of the metabolism process, the phase 1. And then for the phase 2, we have the glucuronide or sulfate conjugation. So we had this in our PharmChem 2, the 2 phases of metabolism. The phase 1 involves oxidation, reduction, and hydrolysis. And then sa second na phase, ito yung mga examples, glucuronide or sulfate conjugation. Now, classifications of our alcohol, pwede silang i-classify based on the number of ARB or any functional group bonded to the carbon bearing the hydroxide group. So kapag isang carbon lang like CH3OH, ito yung tinatawag na carbinol. The old name for alcohol class is carbinol. Okay, yan yung tinatawag na carbinol. Diyan. Now, pag sinabing primary alcohol, ang meaning yan, if this is the carbon containing or bearing the OH, this carbon is also bonded to another carbon. Pero isa lang ha, so one carbon here. So kung iko-kompleto natin with the hydrogen, this one, the ethyl alcohol is considered a primary alcohol. But when you say secondary alcohol, syempre dalawang carbon din. So we will be like erasing this one and papalitan natin siya ng isang carbon. So 1, 2. 2 carbons being bonded to the carbon bearing the OH. So ano example natin kanina dito? The ethyl alcohol. This time we call this isopropyl alcohol. So do not forget, isopropyl alcohol is a secondary alcohol. Okay? Now, kapag tertiary alcohol naman, let me delete this one first. The tertiary alcohol, syempre, you also have 3 carbons bonded to the carbon bearing the OH. So this one is an example of a tertiary alcohol. So how do you call this? Tert 1, 2, 3, 4 butanol. This is called again tert butanol kasi tertiary yung ating alcohol. And then butane, 4 na carbons, 1, 2, 3, 4, and then the all for the OH. Again, that is what you call tert butanol, and that is an example of a tertiary alcohol. Questions about this classification of alcohol? Si methanol or si carbinol hindi included dyan. That's a special case and that's the original carbinol class. Kasi wala namang carbon na nakaband dyan. Kasi isang carbon ka lang naman for the methanol. What is the other name for methanol? What is the common name class ng methanol natin? Anyone who knows the common name of methanol?
Wood alcohol, ma'am.
Very good. It's the wood alcohol. Can we consume the methanol?
No, ma'am.
No. What will happen sa inyo pag makakonsume ng methanol? Matsugi agad. Agad-agad. Yeah, very good. Maglabo ang mata. Methanol can cause class blindness. Okay? And then, syempre, makamatay. Diba? We know that may balita sa una na poison with the methanol. So how about the ethanol? What is the common name for ethanol? If the methanol is the wood alcohol, very good. The ethanol is the grain alcohol. Now, sa metabolism, idagdag ko lang pala, no? Sa metabolism, remember, sa phase 1, it will undergo oxidation. Ang tandaan nyo lang, class, pag primary alcohol, ang oxidation process niya is mako-convert siya first into aldehyde. And then further oxidation of the aldehyde will give you carboxylic acid. This is the process of the oxidation of the primary alcohol. So just like methanol, inside the body, we have the so-called alcohol dehydrogenase. This is the enzyme in our body that will facilitate the oxidation of methanol to formaldehyde. Okay, so magiging formaldehyde siya. And further oxidation of this using the aldehyde dehydrogenase, formaldehyde will be converted into formic acid. So this one actually causes the blindness. Kapag naging formic acid na si methanol. But board exam question, ayun, formic acid yung nagko-cause ng blindness. Pero actually the bees and the ants also release formic acid, and that will be the cause na kapag masting ka ng bees or ng ant, makate siya na masakit, 'di ba? I don't know kung nakatry na mo anak, pero that is because of the formic acid. Pero since that is external, So, wala namang kaso kung dili lang yung katabangan sa bees, no? Pero pag
Di ba ma'am gaburot?
yeah,
Dahang ka
nagaburot.
na ano.
Yeah, that's because of the formic acid also released by the bees and the ants. Pero pag ininom mo talaga internally yung methanol na magiging formic acid, ayan yung mag-cause ng blindness. Okay? Now, for ethanol, sample na nagahubog-hubog din hino. Parehas lang class, parehas na enzyme, alcohol dehydrogenase. But this time, this will become acetaldehyde. And this one causes hangover. Okay, hangover. And then the same enzyme, aldehyde dehydrogenase, will make this acetic acid. Pero si acetic acid, more on makita natin siya sa urine na of the person who consumes alcohol. Acetic acid. Pero yung nagkakos talaga ng hangover, si acetaldehyde. And most of the time, I mean, most of the Asians lack actually aldehyde dehydrogenase. So we cannot really fully and easily metabolize the acetaldehyde. So it will stay longer in our body. Mauna siya ang explanation why yung mga Asians pag nagainom ka ng mupula gani pag maayo, ano mupula kaayo red himong red man. That is the explanation. Most of the Asians lack aldehyde dehydrogenase to further metabolize the acetaldehyde to acetic acid. Yeah, Asian flush. Daw lisod man ano explain sa ila. Kinsan dapat explain na nana. Ang mga palahubog, ano ayun kanang mga termi mamula murag abi nimo di allergy, pero actually that is not allergy. Ano lang jud, we lack the aldehyde dehydrogenase to further metabolize acetaldehyde to acetic acid. It's not because they are allergic to alcohol. Okay? They just had hangover because of too much acetaldehyde in the body. Now, what is class the antidote of methanol poisoning? Example, accidentally you have consumed methanol. What will be our antidote? Very good. It's ethanol. Do not forget that, ha. The method will be, or the process will be, or the mechanism of action will be competitive inhibition sa enzyme. Okay? Competitive inhibition sa enzyme. Since they have the same enzymes for metabolism, ethanol will be competing with methanol with these enzymes. Kasi we are like inhibiting the oxidation of methanol. We don't want formic acid to be formed because this is the one that will cause the blindness. I hope that is clear. Okay? Again, I hope that is clear. Now, how about the secondary alcohol? If we metabolize the secondary alcohol, we will get ketone here. Okay? Primary alcohol will have aldehyde and then carboxylic acid. Tertiary alcohol will become a ketone. Now, how about the tertiary alcohol? This one is not oxidized. Okay? There is no free carbon just like this one. There is no free carbon for oxidation already. Since ito lahat ng yung carbon mo na bearing the OH is already bonded to 3 other carbon atoms. So, hindi yan siya na-oxidize. Okay? Questions? Before ta mag-move on. Wala. Sure na. Now, another classification of our alcohols is based on the number of OH groups. Okay, number of OH groups. We call that monohydric if one OH only, just like ethanol, methanol, isopropyl alcohol, monohydric sila lahat. Pero pag naging dalawa na OH, dihydric and polyhydric for many OH in one compound. Okay, so just like like glycerol. Sino akong pen? Wala akong pen. Like si glycerol looks like this. So this is CH, CH2, and CH2. So again, this one is the glycerol. So this can be considered as polyhydrate. Here. Okay, now how do we name alcohols? Class, if it is just a common name, you're just going to name the alkyl group based on the number of carbons plus the word alcohol. So like we have CH3OH, you have here one carbon, we call this methyl, and the OH will have the alcohol. Therefore, we have methyl alcohol. And then we have CH3CH2OH. We have an ethyl group and then an alcohol, so ethyl alcohol. So the one that we use nowadays, like yung sa mga products natin, methyl alcohol, ethyl alcohol are just called common names. Okay? Now, meron din tayong actually derived names ng ating alcohol, and that will be using the word carbinol. Diba? That's the old name of our methanol. So supposedly, you have here the methanol, right? Isang carbon ang methanol. So this is what you call the carbinol. So ang naiwan, isang carbon, kaya tinawag siyang methyl carbinol. That's how we make the derived name of our alcohol. Pero kapag kaayupak name, ayun yung gagamit tayo ng ol sa ending. Magiging suffix siya. So the parent chain, ganun, similar pa rin yung rules sa naming with that of the alkanes. The first thing that you need to look is the parent chain, the longest chain, but you have to consider that in counting the parent chain, it has to bear the hydroxide, the OH. Okay? And kung saan yung position ng OH, saan siya pinakamalapit, that should be given the lower number. Okay? So we will still use the anong tawag doon? Prefixes sa naming, like pag one carbon, meth, eth, prop, but, and so on. Pero again, the ending should be an ol. And then we also have to number the position of the OH. So okay lang ito. This will just be propanol. Pero this time, kasi propanol is nasa terminal yung OH. Pero ito kasi siya, the OH is found in carbon number 2. So you really have to write 2, meaning this 2 will represent the position of the OH. So tatlong carbon pa rin yan. We still call this 2-propanol. Okay, 2-propanol. Yan siya. That's how we make the ayupak name of alcohols. Any question? Wala. Okay. Again, we are done with the oxidation of alcohols. So please take note of the products of the oxidation of primary and secondary alcohols. And then, for the tertiary alcohols, we don't have oxidation with this. Walang reaction due to the fact that we don't have free slot for a carbon. Okay. Now, we also have testings for our alcohol. We have here the Lucas test. The Lucas test. We have here the zinc chloride as the catalyst. Take note, in the Lucas test, the zinc chloride will be the catalyst and the concentrated hydrochloric acid will be the reactant. Let me show you an equation of the Lucas test. Ay, yari. Wait lang. Ano makita sa screen? Ay, ayan na. Okay. We have here sulat. Aluag dyan ang So like if we have ROH, now that's the alcohol, so any alcohol. And then you have there the HCl as your reactant. And then again, the zinc chloride will be a catalyst. Sulat ko. Okay. So again, the zinc chloride here will be the catalyst. So what will happen is that madi-displace itong OH, papalitan siya ng Cl. So this will become RCl plus water. So again, na-displace si hydroxide plus yung hydrogen ni hydrochloric acid, kaya may water ka dyan. And then the resulting compound will be RCl, or we call this alkyl chloride. So depende yan siya sa R ha. So kung CH3 yan siya, ay hindi mabasa. So like if methanol yan siya, plus the HCl, and then the zinc chloride will be the catalyst, you will have CH3Cl, again, magiging RCl man, so CH3Cl plus you will have the water. That's the Lucas test. And double displacement, if you can see the reaction in the screen, this one is a double replacement or double displacement as type of reaction. And baliktad ito, kung sa oxidation, si tertiary yung no reaction. This time for the Lucas test, it's the tertiary alcohols that will be the most reactive. Okay? And the primary alcohols will also react, but kailangan muna niya ng heating. So, hindi agad-agad mag-react yung mga primary alcohols with the Lucas test. Kailangan pa i-subject natin for heating before we can see the positive result, and that is the formation of two immiscible layers. So this again is a test for us to know the type of alcohol. Ang pinaka magre-react again si tertiary alcohol. So baliktad sila with the oxidation. So tertiary muna, and then secondary and primary in terms of the rate of reaction. And also, alcohol can undergo dehydration. So when you say dehydration, we will be getting rid of the OH. Just like when you have an ethanol, so di ba ethanol is CH3, CH2OH, and then mag-undergo siya ng dehydration. One example of a very good dehydrating agent is the concentrated sulfuric acid, or yung fuming sulfuric acid natin. Now, when the alcohol undergoes dehydration, syempre mawawala itong OH, ang maiiwan CH3CH. Dalawang carbon, pero this will form an alkene. Okay? Alkene class yung magiging product ng dehydration ng alcohol. Pero you will have water. Remember the displaced OH here and another hydrogen being displaced also. So HOH, you have the water. But then again, you have to take note that when alcohol undergoes dehydration, your product will be an alkene. Okay, sorry, that's an alkene. And alcohols also react with metals. Pwede din silang mag-react with metals. Remember, the bond can be ion-dipole interaction. So you have there an alcohol, any alcohol ha, kasi yung R is any functional group, plus an example of a metal, we have here the sodium, and you will have class the formation of an alkoxide. Diba ang ether, if you are going to write the general formula of ether, that's ROR. So the R's class, remember, are any functional groups there. So pwede itong carbon or hydrocarbons, and this can be considered another R here. So the oxygen is at the center. Therefore, when alcohol reacts with metals, you will have an alkoxide. And this one, the hydrogen gas. So take note of this. This will be a gas in a gaseous form. na mawawala lang din in air. But the positive result or like the visible result if the reaction between the alcohol and the metal class occurs is ito, evolution of gas. Okay? So kapag sinabing reaction of alcohol with metals, the one that is most reactive is the methane, followed by the other primary alcohols, the secondary alcohols, and lastly, the tertiary alcohols. So pabaliktad yung reaction naman with that of the Lucas test. Okay? So questions so far about our alcohols before we'll proceed with the phenols. Wala. Sure? Wala na sila paminaw ba? Okay, let's move on to our phenols, or we call this the phenolics. Lupad na ini hang otok. Make sure nga mag-study yun ha kay I believe busy mo pero you really have to give time for this subject kasi you cannot also graduate if you don't pass this subject. And I told you many times na ay mga dating batches na hindi talaga nakagraduate because of this. Kanilang pa jud. So be mindful of that. Na kailangan yapon ninyo ni siya studyhan ha. A review class, isa lang ni siya ka-subject pero syempre madugo gyud ni siya kay review man siya for the boards. Okay? Next, we have the phenols or the phenolics. So this one is a class of compound na merong benzene ring and syempre the OH. So you have the aromatic hydrocarbon group and then we have the OH. So compared to alcohols, the phenols class have higher acidities. So mas acidic sila sa phenols. Mas acidic sila kaysa sa alcohols. But just like alcohols, they can also form ion to dipole bonds. So they can react also with ions. They are the dipoles. And they can also have hydrogen or form hydrogen bondings to other molecules. And parehas sila actually, mostly parehas sila ng properties ng alcohol. They also enhance water solubility. If, for example, the compound class, a very big compound, meron siyang phenol na functional group, that will render the whole compound soluble sa water. So like yung mga scientists and pharmacists, pag gusto nila yung substance maging soluble sa water, either they add OH or they add the phenol. And just like also with the alcohol, they can be esterified para maging prodrugs. So most likely pare-parehas sila ng properties ng mga alcohols natin. But just like also with our alcohol, they are also susceptible to oxidation, especially in the presence of air. Phenol can be oxidized, and in the presence of the metal ion, especially the ferric one, maka-oxidize din siya ng phenol natin. Now, inside the body, how do we metabolize phenol? So we have here class phase 2 metabolism, sulfation, glucuronidation, the aromatic hydroxylation, and the O-methylation. So, almost similar din with the alcohol. May mga additional lang tayo. Since sa alcohol, we only have the sulfation and the glucuronidation for the phase 2 metabolism, and we have the oxidation for the phase 1. So, take note na lang yung pagkakaiba nila. Phenol is more acidic. Now, what are the examples of the phenols? Actually, the phenols can be classified under sa alcohol since they have the OH. But aromatic ring lang talaga dito. Remember yung catechol, resorcinol, and hydroquinone have been mentioned as part of the dihydric alcohols, yung dalawang OH yung present. So, under pa rin sila sa phenols class. So, almost similar to the phenols and the alcohol. And then we also have the 1-naphthol and the 2-naphthol. I don't know if nag-online kayo sa biochem, pero sa biochem nyo mostly makikita itong mga reagents na ito. 1-naphthol, 2-naphthol for testings. May mga testings, maraming testings sa biochem na gumagamit ng mga reagents na ito. But they are examples of our phenols. Okay? Now we have the ethers, or also known as organic oxides. What you have to take note about ethers is yung structure nila. You have the oxygen in the center. So you have your R group, and then another R group on the other side, and then in between will be the oxygen. Now the R group can be any functional group ha. Pwede din siyang aromatic group. So pwedeng benzene ring tapos sa gitna yung oxygen, and then another benzene ring naman. And then pwede din siyang combination of the two. You have there the aromatic ring or the benzene ring, and then at the center still the oxygen, and then on the other side you will have like any functional group, any hydrocarbon na nag-attach dyan sa ether natin. Now, how do we name our ethers? Kapag ka-ayupak names yan, we will be using alkoxy as the prefix. So yung alkoxy is dependent on the number of atoms. So just like this one, CH3, and then this is the O here. So this is R, O, and this is R. So yung R here, ito yung magiging part ng alkoxy. Isang carbon yan siya. So instead of alkyl, ipapalitan mo siya ng prefix na ginagamit talaga natin, meth, and then idugtong mo yung oxy. And ano yung naiwan sa other side? It's methyl group. We just call it methane. So ganyan yung pag-name ng ating ethers. Methoxymethane. Okay, wait lang ha. Give me 1 minute. Okay, let us continue. So again, we have here methoxymethane. Now, for example, you have this one, CH3, CH2, O, CH3. So we can have this part as the alkoxy. So we can have the ethoxy, and then since this one is just one carbon, we call this methane. So that's how we name the ethers. Okay, we can also number the positions if ever there are still like mga branches pouring sa kung complicated na kayo ang structure for the ethers. That's the IUPAC naming. Now, we also have derived names for our ethers, and ito yung parati nating nakikita sa mga names na may ether talaga. So just like the alkyl group plus the ether, you have two alkyl groups here, so we will call it dimethyl, and then the oxygen at the center, so you will have the ether. Okay? So, meron tayong classifications of our ethers, the open chain, merong symmetrical kapag ka the same functional group. So, just like this one, parehas kasi silang methane, so symmetrical ang tawag dyan. Pero if the R groups are not similar, kagaya nung next ko na example, this one is an ethane, you have the oxygen, and then the ethyl. So, hindi similar yung R groups on both sides, we call that mixed ethers. Okay? Yan yung classification. But that is for the open chain kasi meron din naman tayong cyclic ethers. Now, for the cyclic ethers, we have epoxides, or we call this oxiranes or oxacyclopropane. Ito yung mga cyclic ethers with the ether oxygen as a part of a three-membered ring system. So just like this one, you have here the oxygen class, part siya ng ring. Okay? Part siya ng ring. So like three-member. This one is carbon here pero naka-ring, and then the oxygen is part of the ring. Ito yung tinatawag nating epoxides, oxiranes, or oxacyclopropane. Pero there are also class ring ethers na more than 3 members. So pwede din yun siya, under pa rin yun siya sa cyclic na mga ethers natin. Okay? Now, what are the examples? Other examples of our ether? The diethyl ether. Dalawang ethyl on both sides. They are the first anesthetic discovered. In our pharmacology, we have discussed anesthetics, both local and general anesthetics. But the first one talaga na ginamit in practice is the diethyl ether. And then we have the ethylene oxide. We have mentioned this also sa PharmChem 2. And then ginagamit siya 'di ba in disinfecting, okay? Disinfecting non-autoclavable na mga equipment. So like sa mga laboratories natin, when we want to clean our equipment, we subject them to autoclaves. But there are equipment that cannot withstand heat and pressure. So, ang ginagamit lang natin is chemical disinfectants, just like the ethylene oxide. And then we have the monobenzone, which is a pigmenting agent sa plants. Another one is the eugenol. You can encounter this sa pharmacognosy. It's a component of clove oil, or scientific name is Eugenia caryophyllus. Eugenol is ginagamit as toothache drops, okay, sa mga dentist. And we have the drugs naproxen and gemfibrozil, na if we are going to look at their structure, we can really see ether as one of the functional groups present. So si naproxen is under the NSAIDs. It's actually a propionic acid derivative na NSAID. And then si gemfibrozil is an anti-hyperlipidemic agent, which is a fibric acid derivative. Mga examples lang yan sila ng ating mga ethers. Okay? And then we have the amines. But yung ibang tao, yung iba, ang basa nila ng amines is amine. I don't know the correct pronunciation though, but I call this amines. These are class organic compounds that are actually derivative of ammonia. Now, just like the alcohols, we classify them as either primary, secondary, and tertiary. And it's dependent also to how many carbons are being linked in the NH2 or the nitrogen. So if you have primary amine, then you only have one carbon attached here. Syempre, pag secondary, but though R can be any functional group as long as the one attached to nitrogen is dalawang carbon, ayan, secondary yan siya. And then we have the tertiary also kapag katatlo. Now we have quaternary nitrogens also, yung uubusin talaga lahat. Papalibutan ng R groups or yung carbon groups. But what you have to know about the quaternary amines is hindi sila basic. Kasi yung primary, secondary, and tertiary, alkaline yan sila. Basic substances yan sila. So if we test it sa pH, talagang makakakuha tayo ng basic na pH. But that is not true for the quaternary amines. They are not basic because they don't have lone pairs of electrons present. Si primary, for example, kasi meron kasi siyang lone pair. If this is connected to a carbon, and then you have two hydrogen, meron kasi yan siyang lone pairs of electrons that are not bonded, that are not bonded to any atom. So that makes that makes the amines basic. Except for quaternary, since wala ka na talagang lone pairs na naiwan dyan, hindi na siya magiging basic substance. Okay, so please take note of the exception. So what are the drugs that are, or the substances na examples of our amines? We have the aniline, na ginagamit natin sa mga procedures natin in the laboratory. Our neurotransmitters and hormones, norepinephrine and epinephrine, that govern the sympathetic nervous system, also have amine in their structures. The amphetamine itself, from the name, the barbituric acid, which is the parent compound of our barbiturates, used as sedative hypnotics. Well, daghan og gamit si barbiturates, but originally that's a sedative hypnotic. And our artificial sweetener, the saccharin. Okay, that also includes amine in its structure. So these are again the examples of our amines class. Okay, questions before we'll move on to hydrocarbons with carbonyl function groups. Hindi na ako maka-quiz. We will just schedule another day for our quiz with the PCOG, and then another day for the remaining concepts. So orgam, hindi din natin ipagsabay-sabay kay mabuang na siguro mo anak kung atuan ni siyang isabay-sabay tanan. Nag-duty pa, mag-study pa, mag-quiz. Mag-quiz po, ako estudyante ani pagkahuman. Na-deactivate na. So paki-ano na lang, paki-antay yung schedule natin for our quiz. Okay? Walay question about sa amines, sa phenols, and even sa alcohol? Sure? Sure na gyud. Ako na i-question. Ang dili ka tubag absent karon. Ang dili ka tubag absent sa attendance. Charot. Pag dili man katubag kay meaning ana natulog man na, so absent na ay buhi di ay abi mura ako natulog na. Ang dili katubag ba, I mean pag na ako'y pangutan niya wala jud, as in crew ana lang mo na absent na siya kay natulog naman na. Alive pero not sure. Naglutaw man siguro ni sila karon ay. Naglutaw mo. Abot sa inyo. Unsaon na lang nato ni. You find time to rest and then afterwards makibaka. Okay? Ayaw isagad tanan. Kay ma-exhaust mo. Okay.
Wala pa na stop ang recording.
Kailang na. Anyway, we have hydrocarbons class with carbonyl functional groups. Ang inyo lang tandaan, if you hear the word carbonyl, this always refers to carbon double bond oxygen. Ano lang? Pag makita ninyo na siya, carbon double bond O, ayan, carbonyl group, yan siya. Okay? Kapag merong ganyan, automatic under sa carbonyl group. So what are the examples of the functional groups na may C double bond? Oh, sa mukha. Inunday ninyo siya. Ma'am, we need rest. So like when you say class formaldehyde, formaldehyde is like this, C double bond O and then H. So isang carbon ka lang talaga. When you say form kasi, this is our prefix na ginagamit for the derived names of our compound with one carbon only. But as you can see, you have there the carbon double bond O. That is why aldehydes class will be under the carbonyl function groups. Okay, but I have mentioned a while ago that when you oxidize alcohol, it will become aldehyde, and then further oxidation will give you carbolic acid. So nasa gitna si aldehyde class. Nasa gitna si aldehyde. If you reduce aldehyde, you will get alcohol. If you oxidize aldehyde, you will get carboxylic acid. Nasa gitna siya. So this one is oxidation here. And pagpabalik, that's reduction. So we have lots of aldehydes nowadays in the market na, I mean, ginagamit natin no, for our day-to-day living, just like our vanilla, from vanilla plantifolia na plant na ginagamit natin as like flavoring agent. It actually contain vanillin, which is an aldehyde glycoside. So aldehyde ang kanyang functional group. Now, how do we name our aldehyde? Parehas pa rin ng alkane na pattern. Try to look for the parent chain first, but you have to make sure that the parent chain will have the CHO. Okay? Dapat andun sa parent chain si CHO. But instead of ane, ending na ane, or for alcohol, that's all. This time for aldehyde, the ending should be al. Okay, like methanol, ethanol. So yung formaldehyde kanina na C double bond O and then H, 'di ba? Ito yung formaldehyde. Okay? But when you say IUPAC name, we will just use the prefix again, like methane, pero hindi siya methane, mag-e-end siya sa al. So we call this methanol. Okay? Pag dalawa, ethanol, propanol, butanol, and so on. So the only difference with alcohol na naming is all si alcohol, al tayo with the aldehydes. But we also have like common names, no? Yun yung ginamit ko kanina, yung form, yung asset. Yung prop actually can also be used here for the common name. That's the number of carbon. Pag asset class, isang carbon. Pag form, isang carbon. Pag asset, dalawang carbon. Pag prop, tatlong carbon, and so on. Plus the word aldehyde. So we call it formaldehyde or acetaldehyde. And I forgot the other prefixes. Let me research for that again kasi I think it's almost similar with the IUPAC na naming, pero yung kaibahan lang is susunod ito sa ending na al, ito you will have the whole word na aldehyde. Okay? And then meron din tayong derived name for our aldehyde. Ito yung makikita nyo na this will just name the alkyl group kung ilang carbons yun, and then followed by the word aldehyde. So like meron kang isang carbon, so that's methyl, plus the word aldehyde if meron siyang double bond O and H. Okay? Pero we will always use the IUPAC name for the naming of our aldehydes. So again, what are the examples of our aldehydes? We have the formaldehyde, which is a product of metabolism or oxidation of our methanol. And diluted formaldehyde is called formalin. And I believe you know this is an embalming fluid. So it's an aldehyde. The embalming process first happened sa practice yan ng mga Egyptians. And then we have the benzaldehyde that is also used as actually sa flavoring ata ito pa rin ng food products. And then we have the vanillin. I have mentioned this from Vanilla planifolia. It's a plant class. Doon natin kinukuha si vanilla. And si chloral hydrate, which is known as knockout drop. Diba? Knockout drop itong chloral hydrate. And then the citral, which is the volatile oil component of our citrus fruits. Yan yung nagiging responsible sa characteristic odor of our citrus fruits, the citral. So aldehyde yan siya. And then, under pa rin sa ating carbonyl groups, we have the ketones or RC double bond OR. So what's the difference between aldehyde and ketone? This is RC double bond O and then H. Ito yung aldehyde. Now for your ketone, get rid of that hydrogen and then this will be replaced with another functional group. Okay, so this is for the ketone, R-core. Okay, ketone yan siya, and ketones can be made by oxidizing our secondary alcohol. Si aldehyde doon siya sa primary alcohol. Now, how about the naming of our ketone? For IUPAC naming, this will still follow the rules we have with the alkanes, alkenes, and alkynes. You will still look for the parent chain. That's the longest chain in the structure. But you have to also make sure that the longest chain should bear the C double bond O group. And you start the numbering there kung saan pinakamalapit si C double bond O. But instead of like methane, diba, mag-end siya sa ane, or in for alkene, all for alcohol, al for aldehyde. This time for ketone, mag-end tayo ng on. Okay? So, wala tayong methone ha. Kasi remember, RC double bond OR na ito. So, ilang carbons na yan? Wala tayong one carbon ketone class. Okay? Ang ano lang, 2 carbon magsa-start yung ating ketone. So like meron kang C double bond O and then meron kang CH3 here. Dito, pwede ito maging ketone kahit wala na itong R dito. Ketone pa rin ang tawag dyan as long as you have the C double bond O and then the R. So dalawa yan siya class. So, di ba, ethan. And then, palitan mo yung ending with on. Okay? No. Kailangan may R pala ito. Baliktad. Lagay pala natin yung CH3 dito. So magsa-start pala ang ating ketone with 3 carbons. So we have here the propanone pala. This will be our start. Propanone, or we call this actually the acetone. Ito yung acetone na tinatawag natin, ginagamit natin as nail polish remover. It's actually a ketone. Pero yung acetone, ginagamit din siyang solvent, but this one is very volatile. You have to secure first permit from PDEA if you're going to purchase a lot of alcohol. Kaya kung nakikita ninyo, very limited amount lang yung binibenta nila because acetone is one of the raw materials for making methamphetamine. Okay, now for the common or derived name, we just name the alkyl group kung ilang carbons yan ang involved dyan and just add the word ketone. Okay, so just like this one, you have the CH3 and then the CH3 there. So you will have dimethyl and then the ketone at the center. That's how we name the common or the derived name for our ketone. So again, what are the examples of our ketones? I have mentioned acetone a while ago, and then our male hormone testosterone. We are going to elucidate the structure of that. We will also see na it bears a ketone in its structure. And then the moscone, ginagamit itong ano, 'di ba? Ingredient ng perfume, the moscone, pero hindi ko gusto yung amoy nito. Parang sa Middle East, marami sila nito na perfume bearing the moscone. Coming from, ano yun? Anong organism yun? It's coming from an organism and it gives off odor. That is why parang component siya ng perfume. Pero again, hindi ko siya feel. Okay, metabolism of ketones. So ketones are very stable. So ketone cannot be oxidized ha. Kung nakita niyo yung pathway ng secondary alcohol natin kanina, pag na-oxidize siya, hanggang ketone lang siya. Unlike the aldehyde na pwede pa siyang convert into carboxylic acid. This time, the ketone will just be a ketone. It's stable, but it can be reduced back to secondary alcohol. Take note, it should be secondary alcohol. That's for our ketone. So let's have an exercise. Name the following. You have the first one and the second one. Syempre, they are different. Let's have your participation sa class ngayon. Can you name Ayupak? I want the Ayupak name for number 1 and number 2. Let's see. Anong hulaton ba? Yes, Sarah. You can send your answers sa chat box. Iano lang private message. Ito na tong uban. Kasi ano pa. Nagsulat pa. Wala na? Wala na ni tanan? The first one, how many carbons is that? 1, 2, 3, 4. Apat na carbon yan. So what will be our prefix for apat na carbon? 4 na carbons. It should be bute. Tama? Actually, butane yan siya kung ano siya. Pero, this is CHO. The ending is CHO. Ano ibig sabihin? Archo. Di ba this one is an aldehyde pag archo? Ano tawag dito? Butanal.
Butanal.
Okay. Not butanol ha. It's butanal. Because this one is an aldehyde. This is not an OH. Cho yan siya. Archo. Okay. Butanal. Now, how about this? The next one. How many carbons will this be? 1, 2, 3, 4, 5. 5. Okay. What's our prefix for 5?
Prop.
Huh? Prop is
Pen.
10. Okay, pen.
Pen.
Okay. Okay, ganito mag-name ha. You have to actually state kung nasaan si C double bond O. Okay? But you have to number class starting kung saan siya pinakamalapit. So you will not start here as carbon number 1. Dito ka dapat mag-start kasi dito malapit si carbon double bond oxygen. So this is 2, 3, 4, and 5. So nasan ba si carbon double bond O? We have here at carbon number 2. So you can call this pentan 2-one or you can just call this 2-pentanone. Okay, ganyan mag-name class ng ating ketone. This is a ketone. The whole, this one, the whole carbon chain is the R. Then you have the C double bond O and the CH3 is considered an R. So RC double bond OR, remember, this is our general formula for ketone. Itong nasa taas kanina, this one will be the whole R and then CHO, CHO, that is an aldehyde. That's how we name class a ketone and an aldehyde. So you have to again state saan nakalagay si C double bond O, especially for ketone. Kasi yung kasi si ketone class, yung C double bond O, pwede din namang nandito siya or pwedeng nasa gitna siya. So kailangan natin siyang talagang i-identify saan banda yung ketone makikita. Pero bilangin mo muna ilang carbons yan. 1, 2, 3, 4, 5. Okay? And then replace the ending with -one. Okay? Questions? That is not an ether. Gagamit lang tayo nung yung alkoxy, like butoxyethane, methoxymethane. Gagamit lang tayo niyan pag ether yan siya. How do you know an ether? An ether is just ROR. Wala yan siyang double bond class. Like you have CH3 and then O lang yan siya diretso and then another CH3. Hindi kagaya ng ketone na you will have example CH3, CH2, and then yung C dyan, naka-double bond actually sa oxygen. Before ka magkakaroon ng another R, which is pwede siyang CH3. Okay? Huwag malito ha between ether and ketone. Ayaw kalimti ang double bond. Ang ether class, O lang din siya sa tunga. That's a single bond. Okay? Sige, questions about that? Wala. So, how about the oxidation of our aldehyde and our ketone? Kailan natin gagamitin si Benedict's test? Anyone? Kailan, anong gamit ni Benedict's test? Oxidation actually ito ng ating aldehydes and ketones. Sa sugar, yes, tama sa sugar. Tama.
Reducing sugar.
Okay, very good. Test for reducing sugar. So actually, ang ginagamit na reagent dito, di ba, is si copper. Okay, si copper. So if you have, for example, an aldehyde, any aldehyde, so like you will have your archo there, reacting with the copper ion, you will have this one, RC, double bond O, and another O here plus the copper oxide. Ito yung magiging reaction. So again, any aldehyde yan siya. And then itong copper oxide will be the one responsible for the positive result. Diba? Ang positive result ng ating Benedict's test is brick red precipitate. Ito yon, formation ng copper oxide. And that will signify that yes, the archo here, na-oxidize niya itong, no, wait lang ha, positive 2, reducing sugar pala siya. So, na-reduce niya itong copper ion into copper oxide. Okay, kasi reducing sugar ito. Pero hindi lahat ng sugar ay reducing. Pero ito yung ating formula for the Benedict's test. So one example of a sugar that is not reducing is the sucrose. Pero sugars like glucose, maltose, lactose are reducing. If you're going to add copper ion here, there will be formation of this copper oxide, which is the reduced form of copper, and that is brick red in color. So again, that will signify that indeed the sugar is a reducing sugar. It can reduce copper. Okay. Now, how about the tolerance test? Can you remember the tolerance test? Or what's the other name for the tolerance test? This is the silver mirror test. But this is actually for aldehyde only. Kasi si Benedict's test can also be used for ketones. Remember, our fructose, our fruit sugar is a fructosan. So fructose yan siya, but it is also a reducing sugar. So it can also reduce the copper ion. Pagdating sa tolerance test, this is also again known as the silver mirror. And this is for aldehyde only. So ano yung reaction? Reaction nito. So example, we have here an aldehyde, the archo. And what will be the reagent for our tolerance test? Anong reagent natin dito? Ammoniacal. Let me write. Ammoniacal silver nitrate. Okay, ammoniacal silver nitrate. So you will have the silver there that will be the one reacting with the aldehyde. And you will actually get this same na product when it comes to the aldehyde class. Pero ito yung makikita natin na positive result. The formation of the silver ion. And ito yung tinatawag natin na silver mirror. Okay? Again, yan yung tinatawag natin na silver mirror. And this will only be visible if the substance that you are reacting with silver is an aldehyde. For ketone, we cannot see a silver mirror here. So tama na tolerance test is used to test the aldehyde. Now, how about the iodoform test? How about the iodoform test? Saan naman natin ito ginagamit?
For carbonyl compounds, ma'am.
Okay, anong ibig sabihin ng carbonyl? Remember, it's carbon, double bond, O. So we will be testing the presence of a carbonyl functional group in a compound using iodoform test. Nakuha? So ano yung mga functional groups na may carbonyl? Pwedeng aldehyde, pwedeng ketone, and then actually yung amides natin, yung esters, and yung carboxylic acids natin also contain carbonyl compound. Kasi yung carbonyl compound always in the C double bond O. So for example, you have a ketone, just like this one. Tapos pinag-react natin siya, yung from the name itself, iodoform test, we will be using iodine here. So remember, ang reagent natin dito is actually iodine. But remember class that iodine is not soluble in water. So you have to have a solubilizing agent. And we are going to use potassium iodide here. And plus meron pa siyang another substance that will aid the reaction, the methyl ketone. So what will be the products here? You will have the CH3, C double bond O, and then O negative, just like with the Benedicts and the Tollens test. But what is unique here is the formation of the CHI3, or this is also known as our iodoform. What is the color of our iodoform? Later, I'll explain what is iodometry in the iodoform test. Iodoform class, anong color nito? This one is a yellow precipitate.
Yellow.
Okay? So take note of that. Iodoform test is used to test the presence of carbonyl group in a compound. So you have here the reagent iodine, but it will be combined with potassium iodide as solubilizing agent in the presence of methyl ketone. So you will have a positive result if there is the formation of the iodoform or the CHI3, which is a yellow crystalline precipitate. Sa kalahian sa iodoform test is for the presence of the carbonyl group. Iodometry is a titration process na ginagawa sa QC to check whether the substance is an oxidizing agent or a reducing agent. Okay? So sa redox reaction under C, iodometry. I forgot though. Kasi dalawa yan sila, iodo and iode. I forgot saan yung oxidizing and saan yung reducing agent. But nevertheless, that will be under the redox sa QC na titration process. Okay? I hope I answered your question. Nakatry kami. Nakatry na mag-titrate. Asa mo nakatry?
Sa Yaki, ma'am.
Ay, pa-titrate mo dito. Ano sige, titrate ninyo? Carboxylate.
Itong ilang vitamins, ma'am.
Sa process sa titration?